Hello and welcome to Team MGF's Six Sigma Implementation Greenbelt Project presentation. Team MGF consists of 3 members, all working at Masters Gallery Foods. Myself, Eric. I am a project development coordinator based out of the R&D department here at Masters. Sarah, who is one of our internal raw materials grading coordinators. Sarah is also a state licensed cheese grader. And Kim. Kim is our first shift QC supervisor. A little bit of history about Masters Gallery for those of you that might not be aware of who we are or what we do. Masters started in 1974 as a small brokerage firm in the business of purchasing, aging, and distributing bulk cheese to industrial customers. What that means is we would purchase cheese, hold on to it, age it, and then sell it to companies that were looking to use that cheese for shredding or slicing and all sorts of uses. In 1989, the business expanded. Our production distribution facility here in Plymouth was built, and big news there was that brought reclosable shred packaging to the private label sector. Before 1989 came along, reclosable shred packaging that you buy in the store was only available through the bigger guys. Private label, meaning your store brands, your Piggly Wigglies, your food clubs. So that was a big step in bringing that availability to more people. We offer dairy-based products to retail markets, as mentioned, buying stuff from the store. Food service, meaning the restaurants and food and distributors, and the industrial market. So company was founded on that purchasing, aging, and distributing cheese. We still do quite a bit of that today. Currently, Masters Gallery Foods employs over 800 people at 2 manufacturing facilities, the main one in Plymouth that I mentioned earlier, and then our newer facility down in Oostburg. A little overview of our project. What started out as just a project for this class quickly snowballed and became a company-wide initiative that involves numerous departments, mainly the engineering department, production, and the quality departments. Our project has already spawned other projects and become sort of a template for applying to other lines. Our project focuses on one specific line, and already some of the things that we've found and what we've learned are being looked at to apply to other lines. Some of the data collecting that we did and some of the things we found have already spawned other projects in other departments, such as the continuous improvement department. Weekly meetings were held, not only with the 3 members of the team, but with other members of other departments, mainly the engineering production departments. Data collecting across all shifts was needed. We run 3 shifts here at Masters, so we look to get data and input from all 3 shifts. And numerous tools and assistance from other plant personnel. We have technology-driven data collecting that is pretty advanced, and we definitely look to the people that know what they're doing with that stuff to help us out. And I'm going to turn it over to Sarah now. Sarah's going to go through sort of the more specifics of the project.
Hello, I'm Sarah Gutman, and continuing on with our project overview. Our project had originally started as an OEE project to up our efficiencies on our line 6. After meetings with the various departments in our company, we soon realized that we actually need to up our availability, so our uptime, so the amount of time that the line runs, by reducing our downtime. So when a line is down, it means the company's not making any money. We, of course, want to make money and increase our capacity on that line. We also do not want to compromise quality or have any increasing costs, such as additional high-cost equipment, or if we can get away with not adding any more team members to the line, then we, of course, will not have that big cost of another employment. We are expected to save roughly $131,000, not just this year, but also in years to come, so every year after that. And we should be done with this project hopefully come midsummer. So while everybody else gets to finish their greenbelt right now, we will be continuing to work on ours through the end of June. Some of the documentation that we have already completed. The first, we have our project charter, and in it our first problem statement states a little bit about OEE as well as adding in the capacity. Next, we have our VOC analysis. So our major customer is the retail shred customer, and like Eric had mentioned, that would be like grocery stores. So if you would go to Walmart or your local grocery store, this line produces those little 8-ounce bags of shredded cheese that mainly you put on salads or you cook with. So obviously we want our quality to be good. We want our finished product to look good. We want it to taste good. We want it to perform for the needs of the customer. And then for delivery, obviously we want delivery time to be what is expected from the customer, but we also want it to get there in good shape. So we don't want our pallets to tip over, and we don't want any damage to the cases or the finished product. And then safety is also a concern, not only to our external customer when they're unloading our pallets, they don't want it to fall, the product to fall on them, but also to our internal customer. So plant management wants us to produce this in a safe manner. And next, we have our SIPOC. Suppliers of raw materials would be our cheese suppliers, film, anti-cake, corrugate, and label suppliers. And then some of the outputs that come with making shredded cheese is not only the little packages of cheese that we sell, but there also can be what is called fish bait, trim, and processed cheese. And then some of the waste is film, anti-cake, corrugate, label backing, and then also we have the labor used to make the product. And here at MGF, we are really big on recycling. We have a green team, so most of our waste here is recycled. And next, we have the process map. And this, while it does look big, and it did take us a while to make this, it also is more of like a first draft. And as we go through our project even more, and in the next upcoming months, we will be adding to this to make it even more in depth. And this is also will be a template for other shred lines in our company for their process map. So just a quick overview on how cheese is shredded. First, we receive the bulk cheese in, and then the cheese gets graded. And here at MGF, we grade every load of cheese that comes in, but it is graded by a licensed cheese grader. And as you can see listed underneath the bulk graded, we have our sensory results, our performance results, and some of the grading tools that we use. Once the cheese is graded and okayed in the system, it goes to our bulk cutting area. So it gets cut down to a smaller size so that it can be put on our production line. From there, it goes to the production line and then gets cubed down. So cubes being anywhere from about 2.5 to 4 inches in length. So it can fit through our shredder. Then it gets shredded. After it's shredded, it gets packaged or bagged, and then it goes into cases or boxes. We have a more tech-driven data collecting environment here. We use an application called Red Zone. And Red Zone is an app on an iPad, and it collects downtime for us. So when it's collecting down, so when a line goes down, the operator can collect the reason for downtime, and it can be anything from a 3-second downtime or a 3-hour downtime. And some of the reasons can include film change or cheese change or a maintenance call, and whatever the reason, they plug it into Red Zone. Other things that Red Zone is capable of doing is it helps us store all our quality checks on the finished product. And then also it shows us real-time data. So if I want to go out to our line 6 and I want to see what's running, how much time they have left, how many cases of cheese they have left, what's next on their schedule, I can just pull up this app and it will tell me everything at a glance. It will also tell me each hour what the efficiency of the line was. So if I see there's an issue around 6 a.m. and now it's 8 a.m., I can go back and talk to that operator and say, hey, what was going on during that time? From Red Zone, we can then import data into Excel, and then from Excel, we can of course put it into Minitab. Thank you, and Kim Schmidt is up next.
Hello everyone, I'm Kim. Now we are going to dig into our data analysis. First, we needed to verify that our data was normal, which it was with a p-value of 0.173. We then used a Pareto chart to outline our top downtime events. The top 3 downtime events are due to cheese changes, maintenance calls, and film changes. After looking into the maintenance call data, we concluded that it wasn't defined enough to apply to our project. This created a new project for our CI team to standardize maintenance call downtime reasons. With that part out of our hands, we decided to focus on cheese changes and film changes. Our next step was to create a spaghetti diagram. As you can see, it turned out quite messy. There's a lot of steps that can be eliminated to save time when changing over both cheese and film. There was way too much walking back and forth to retrieve certain tools. This wasted a lot of time, and we all know that time is money. We then conducted a time study of each step in a cheese change and a film change. Our goal is to have the total changeover be completed in less than 10 minutes. Trimming 12 minutes off each changeover will show a big impact on our availability, especially on the days when there are 30 or more changeovers on one line. That really adds up. So our data overview, we found out that all data and findings were normal. The large amount of data that we had made it possible to quickly determine the process steps that needed our attention thanks to our red zone system. And major downtime reasons were analyzed further, our cheese change and film change. This also made it apparent that standardization when recording downtime is needed and is now a separate project within the CI department. And that's where I brought up those maintenance call reasons. There could be hundreds of reasons that maintenance was called to the line. Our project results. Our time study findings has led to 2 relocating discussions, and I believe these will be easily attainable. Our line operator meetings and observations are taking place to improve and standardize the film changing process. And this will be great across all 3 shifts. As you know, at a lot of workplaces, each shift does something different, and we need to standardize that. Centerlining and SMED projects have also been created due to these findings. That's it for our project. Thank you for listening.